Start with 3D geometry. So the first thing is vector representation of a point. Vector in 3D geometry, how to represent a point. Vector representation of a point. Let's say we have a point x, y, z. In this we will have 3 coordinates because it is 3D geometry. In 2D geometry we had p dash, let's say x comma y, right? But in 3D geometry we have 3 coordinates in x-axis and y-axis and on the z-axis. So this point is represented as xi cap plus yj cap plus z k cap. How's that? Let's say we have this x, this y, and this as z-axis. Fine. So this point will be x distance from here, y distance from here, and z distance from here. This will be your P point. That is x distance from here, y distance from here, and z distance from here. So this will be the position vector of P, of this point, of this P. Now, second is distance formula. That is, if you have 2 points, then how to calculate the distance between them. Let's say you have 2 points x1, y1, z1, and x2, y2, z2. Now, the distance between them is calculated by using the formula d is equals to, let's say, this point and this point, just like what we did in straight lines, just like what we did in vectors or in complex numbers. Root square of, in this case, we will have one extra term of z. x1 minus x2 square plus y1 minus y2 whole square plus z1, this term is extra, minus z2 whole square. Right, so this is the distance between 2 points. Or you can say if this point is A, then this point is B, then AB vector will be, or I must say AB only, this distance AB will be OB vector minus OA vector. Now how is that? It's just like if you have this as origin, this as A and this as B. So OB vector minus OA vector will be AB. Will be AB vector. Okay, just like the sum of 3 vectors. Okay, so this is the thing. This is the distance formula. The third formula is section formula. Section formula says that if you have 2 points, then you can find a point here which will divide it in m:n ratio. The 2 points I will always consider x1, y1, z1 and x2, y2, z2. So let's say this point has the coordinates x, y, and z. Then x, y, and z will be equals to, x will be equal to mx2 nx1 divided by m plus n. Similarly, y will be equals to my2 plus ny1 divided by m plus n, and z will be equals to mz2 plus nz1 divided by m plus n. Fine. So all these formulas are alike, so you will find this coordinate using this section formulas. Now midpoint of 2 points. Okay, midpoint of this A and B will be, let's say, C. If C is the midpoint, then C's coordinates will be x1 plus x2 by 2, just like in the straight line and vector algebra, y1 plus y2 by 2, and z1 plus z2 by 2. So this is the midpoint. Now we'll move on to the direction cosines and direction ratios. Now, first of all, direction cosines. So direction cosines, let's say we have alpha, beta, and gamma be the angles a directed line makes with the positive directions of, or you can say positive directions of the axis of x, y and z respectively. That is, alpha is for x, beta is for y and gamma is for z. Fine. So this is the condition. Then cos alpha, cos beta and cos gamma are called the direction, as we have taken the cos of angles, so this will be direction cosines, fine, of the line, directed line, fine. So these are the direction cosines, and the direction cosines are usually denoted by L, M and N, fine. So L is equals to cos alpha in this case, M is cos beta and N is cos gamma, fine. So these are the direction cosines. Now one relation between direction cosines is that L square plus M square plus N square is always 1. This formula is used in many of the exams like EEE, also in JEE also, and sometimes in boards they ask this question that why is this, how to calculate cos gamma if cos alpha and cos beta are given. So you have to use this formula, this easy and simple formula. Now the next condition is about direction ratios, how to calculate them, how to understand direction ratios. Let's say we have, let A, B, C be proportional to directional cosines. Okay, direction cosines L, M and N. Then these are called, ABC will be your direction ratios, fine. So this is the thing. Then we have next formula as L, connecting the direction ratio and direction cosines. So first of all is L is plus minus A divided by root of A square plus B square plus C square. Similarly, M will be what? Plus minus B divided by root of same. These are all symmetric now. And N will be plus minus C divided by root of A square plus B square plus C square. Okay, the same thing. Now, this is the relation between the direction cosines and the direction ratios of a vector. Okay, so if you have a point, let's say as an example, we have point P, x1, y1, z1. Okay, then, and let's say we have a point Q, which is x2, y2 and z2. Then the direction ratios of the line PQ, okay, the line connecting PQ are A is equals to x2 minus x1. This is the direction ratio. B is equals to y2 minus y1 and C will be z2 minus z1. Fine. These are the direction ratios. Now to find the direction cosines of line PQ, what do? These are proportional to direction cosines. The definition states that. So L will be x2 minus x1. Now what we have to remember is PQ, distance between PQ, mod of PQ, because PQ is a vector. M will be y2 minus y1 mod PQ, and N will be z2 minus z1 mod PQ. So this is how we calculate. If we are given 2 points, then this is how we calculate the direction ratios and direction cosines and their relation between them. Now we will move on to the angle between two line segments. Angle between two line segments. So this is given by cos of theta, which will be a1 a2 plus b1 b2 plus c1 c2 whole divided by root of a1 square plus b1 square plus c1 square and root of a2 square plus b2 square plus c2 square. Okay, so this is the angle between two lines. So a1 I cap, b1 j cap and c1 k cap, a2 I cap, b2 j cap and c2 k cap. Okay, then you have the lines will be perpendicular to each other if this is 0, because cos theta is 0 when theta is pi by 2. So this is 0. Okay, they will be perpendicular to each other. C1 C2 is 0. I'm not giving any examples because this is similar, easy thing. Similarly, parallel if a1 by a2 is equals to b1 by b2 is equals to c1 by c2, just like the straight lines, that if they are parallel, then if ax plus by plus c is equals to 0 is a line, then it will be something proportional to ka plus kx plus kby plus k dash c is equals to 0. Okay, so these are proportional, just like here. So in case of perpendicular, we had minus a by b into minus k by kb is equals to 0. But in this case, we have a1 a2 plus b1 b2 plus c1 c2 is equals to 0 if they are perpendicular to each other. That means this cos theta, you can remember it in this way. Cos theta is pi by 2. Okay, now we will move on to the projection of a line segment on a line. Projection of a line segment on a line. Let's say we have 2 points P, again those 2 points P x1 z x1 y1 z1 and Q x2 y2 z2. Then the projection of this line PQ. Let's say we have this line as PQ. This projection of this line segment on a line having direction cosines. We have a line, let's say this line, then the projection of this on this line, this is the projection, and this line has the direction ratios of direction cosines as Lm and N. Fine. So the projection will be mod of L x2 minus x1, again this, then plus M y2 minus y1 plus N z2 minus z1. Fine. So this is the projection of a line segment on a line. Now I'll move on to the equation of a plane. You have to just apply these formulas and you'll get to the answer. Equation of a plane. A plane is like this. Okay, line is like this, plane is like this. It consists of two axes. So general form of this plane is ax plus by plus cz plus d is equals to 0. Okay, just like x plus y plus z, x plus y plus 2z is equals to 3, just like that. ABC are not all 0. Okay, in this case, anything can be 0, like C can be 0, B can be 0, but all the three can never be 0, are not all 0. And A, B, C and D also, they all belong to R. Fine. So first form of the equation of plane is normal form. Normal form is like Lx plus My plus Nz is equals to P. Okay, this is the normal form. Then second is the plane through the point. If you are given a point, then how to calculate the equation of the plane? So it will be ax minus x1 plus by minus y1. These two are very helpful. Okay, these two are very important and helpful. Plus c z minus z1 is equals to 0. Okay, so if you are given a point and you are given that this point lies on this plane, then it should satisfy the equation of the plane. So that's why this is done. Okay. Third thing, Third is intercept form. Intercept form suggests that x by a, just like in the straight line, y by b plus z by c is equals to 1. Right? So this is the intercept form of a plane. Now we'll move on to the fourth form, which is the vector form. Also important. Can be easily used if you know the vector algebra good. If you have a grasp on vector algebra. So the plane equation is r vector minus a vector. R vector is the defining vector. Minus a vector is equal into n dot n vector is 0, or r vector dot n vector is equals to a vector dot n vector. Here a vector is the point given to you. R vector represents the xyz coordinate, and n vector is the direction of the plane. Okay, so this is how we do the equation of plane in a vector form. The fifth form is any plane parallel to the given plane ax plus by, just the normal form, cz plus d is equals to 0 is, if it is parallel to this form, then just like this straight line, we will have these three same, ax plus by plus cz plus this d will be something else. Just d will be something. It's like this is a plane, okay, and this is another plane parallel to this plane. They are parallel. Then the distance, there will be some distance d minus d dash, but the ax and b will be same for those planes. So this is same, but d minus d dash is the distance. So this is different. Okay, mod of d minus d dash. Now let's calculate the distance between them. So d star, let's say, is d minus d dash mod of that divided by root of a square plus b square plus c square. This is d star. Okay, divided by root of a square plus b square plus c square, which are the coordinates of x, y, and z. So this is the distance between two planes. Now, equation of a plane passing through a given point and parallel to the given vectors. How to find the equation? This condition is given that the plane is parallel to the given vectors. Let's say r vector is equals to a vector plus lambda b vector plus mu c vector. Right? This is the parametric form. And these two are scalars, lambda and mu. Lambda and mu are scalars. And non-parametric form will be r vector dot b vector cross c vector. We have studied these scalar triple product in the vector algebra, so you can view that there. A vector dot b vector cross c vector. So this is the non-parametric form. Both can be used depending on the type of question they are asking, and both are easy to use. This one is more easy. Okay, so this is the equation of plane passing through a given point. Okay, a vector will be given to you and parallel to these given vectors. Okay, b and c are given vectors. A vector is the point given to you, and this is the equation of plane. This can be represented as this too. Okay, now a plane and a point. A plane and a point. First thing about a plane and a point is the distance of the point of a point, let's say x1, y1, z1 from the normal form equation of a plane, from the plane ax plus by plus cz plus d is equals to 0. This is given by, distance is given by a x1 plus b y1, put the point just like the straight lines, plus c z1 plus d divided by a square plus b square plus c square. Now I must say this, that whole lot of formulas from the straight lines and vector algebra connecting both of them will be used here. So 3D geometry is kind of easy if you know the basic concepts of about vector algebra and straight lines, and that will help you a lot through 3D geometry. So first focus on those two chapters, and you will have no trouble in 3D geometry. So just like this distance is just like the same, we have this factor extra, just these two factors c square, because it is connected with a third kind of axis, z axis. So let's move on. Length of perpendicular from a point A vector to a plane. Let's say A vector is this, and it will be length. Okay, in this question, in this formula, there was a point given to you, and plane equation of plane, normal plane was given to you. If you want to find the length of perpendicular from a point A vector, this is a point given to you, and a plane is given to you, which is let's say r vector dot n vector is equals to d vector. Just like the vector form of plane, the point is given to you, and this perpendicular distance you have to find out. So this perpendicular distance, let's say P, is given by a dot n vector minus d, okay, mod of that, divided by mod of n vector. Okay, so this is the distance. Point will be given to you, n vector will be given to you, d will be given to you. So you can easily find the distance, length of perpendicular. Okay, then the next formula is, let's write it on another page. Foot of perpendicular. Let's say foot of the perpendicular was, let's say, x dash, y dash, and z dash. Okay, drawn from the point, we had a point x1, y1, z1. Fine, this was the point, and the plane was, let's say, ax plus by plus cz plus d is equals to 0. This is the plane. We have a point, and this is the foot of the perpendicular. Now, how to calculate the equation, points, the foot of the perpendicular? So x dash minus x1, just like the straight line, y dash minus y1, b is equals to z dash minus z1, c is equals to minus, put the point in the plane. Fine, this is the equation of the plane. Put the point in the plane and divide by coefficient square. Okay, so this is the foot of the perpendicular drawn from the point P. Now, to find an image of the plane, we will use the formula. This for image of a point through a plane, x dash minus x1 upon a. The distance gets doubled, so this will be 2 times. You will not have any trouble remembering this if you know the foot of the perpendicular formula is minus 2 over ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square. So this is the the image, okay, of the if x dash, y dash, and z dash is the image of a point x1, y1, z1 through a plane ax plus by plus cz is equals plus d is equals to 0, then the x dash, y dash, and z dash will satisfy this equation. How to calculate them? You calculate this, you calculate this, and you calculate this. You find the relation between x dash minus x upon a in this. You will be given the value for this. A and B and C will be given to you. X1, Y1, Z1 will be given to you. And you will find the value of x dash, y dash, and z dash from these 3 equations. Now we'll move on to the angle between 2 planes. Let's say we have a plane like this, and we have a plane like this. So there must be an angle between these 2 planes. So first of all, a plane is derived from the normal vector, is defined from the normal vector. So let's say this is the normal vector 1, this is the normal vector 2. So from that, you will just find the angle between these normal vectors. Whatever the angle is between these normal vectors is, will be the angle between these 2 planes. So just like that, we define cos theta as a dash plus b dash. We have defined it earlier. The same formula we'll use here. Divided by a square plus b square plus c square root of a dash square plus b dash square plus c dash square. Okay, and mod of this, that will be the cos theta, angle between two planes. Now, planes are perpendicular, planes are parallel. I have defined that. So we'll use the vector form here. So let's say we have r dot n1 vector is equals to d1. This is the equation for this plane. Then we have r dot n2 vector is r vector dot n2 vector is equals to d2. This is our second plane. Then cos theta will be, in this case it will be n1 dot n2. We have two vectors and we have to find the angle between them. It will be just like the vector algebra. N1 vector, it is the vector algebra's form. Okay, angle between two vectors. So it's just angle between two vectors. Now if n1 dot n2 is 0, n1 dot n2 is 0, then cos theta will be 0. This implies theta will be pi by 2. That is, there is a 90-degree angle between n1 and n2. That means the planes are perpendicular. If n1 dot n2 is, n1 is some lambda times n2 vector, that is, n1 is parallel to n2 or something like that, then let me conclude it like n1 vector is lambda times n2 vector, then cos theta will be 0, cos theta will be 1, so theta will be 0. That means they will be parallel. So you have to see the condition that n1 and n2 is 0 or this. In that case, they will have 0-degree angle, or this lambda is a scalar. Okay, in that case they are 0-degree angle or pi by 2-degree angle. So that depends on this formula. What does this value occur? Now the angle bisectors, the equation of the planes bisecting the angle between two given planes. Okay, so the equation of the plane, let's say we have a1x plus b1y plus c1z plus d is equals to plus d1 is equals to 0, and the other plane is a2x plus b2y plus c2z plus d2 is equals to 0. We have two planes. Then the equation of the planes bisecting the angle between two given planes. Like in this case, let's say we make okay, we have two planes. Let's see this view. Okay, we have two planes, and the equation of the plane which is bisecting these, this is a plane. Okay, and these two green planes can be seen as this and this. Okay, so there is a plane which is bisecting these two planes. This plane is bisecting these two planes, angle between two planes. The equation of this plane will be according to this formula. Just place the first plane divided by the root of a1 square plus b1 square plus c1 square. Just like the straight line formula, this can also be remembered, that a2x plus b2y plus c2z plus d2 root of a2 square. In that case, this element was not there. Okay, which we are including it here. This element was not there. Okay, so that's the difference. Otherwise, it is the same. Now we'll move on to a line. We will focus on a line. The questions are mainly asked from this topic, so keep concentrating on this. Equation of a line. First point, equation of a line. Equation of a line is, a straight line is intersection of two planes. Okay, if there is a plane and there is another plane which is intersecting this plane, so there will be a common line at which this is intersecting this plane. Okay, so the straight line is the intersection of two planes and it is represented by two planes. Okay, this plane 1, this B plane 2. So this line is represented by these two planes. Okay, this is the formation between these two planes. So the equation of lines can be in the symmetric form, let's say we have this y minus y1 by b is equals to z minus z1 by c is equals to r, or we can have a vector. This is the symmetric form, this is the vector form. R vector is equals to a vector plus lambda b vector. These are the equations of line. Okay. Now reduction to Cartesian form of equation of a line, it can be like we can say x minus x1 upon a, just the symmetric form, upon b is equals to z minus z1 upon c. Okay, so the reduction of Cartesian form of equation of a line to the vector form, this can be reduced to r vector is equals to x1 I cap plus y1 j cap plus z1 k cap plus lambda times a I cap plus b j cap plus c k cap. Okay, so this is the formula. A I cap, this is a I cap, b j cap, c k cap vector. Okay, and this is x1 I cap, y1 j cap, z1 k cap vector. So the line will be like this. Okay, so these are the forms in which a line can be represented. Now I'll move on to angle between a plane and a line, how that is defined. So an angle between a line and a plane. Fine. So we have a line. Let's say if we have theta as the angle between this line x minus x1 by L is equals to y minus y1 by M is equals to z minus z1 by N, and plane, let's say we have again the same plane ax plus by plus cz plus d is equals to 0. Then sine theta, we define this angle between a line and a plane. You can imagine it like this. This is the line, this is the plane, this is the n vector, this is the line. So this is the 90 minus theta. So that's why this is theta. So this theta is the angle between plane and the line. But 90 minus theta is the angle between n vector and the line. And as we can calculate only n vector, we cannot calculate anything about this a plane. So because a plane is represented by its n vector, so we have to calculate sine theta, not cos theta. So sine theta will be AL plus BM AL BM CN divided by root over a square plus b square plus c square and L square plus M square plus N square. This is the theta, sine theta. So theta can be calculated by taking the sine inverse of this. Okay. Now we'll move on to condition for let's see some more formulas. Vector form. If theta is the angle between a line, let's say r vector is equals to a vector plus lambda b vector. This is the line, and we can have a plane like r vector dot n vector is equals to d vector. Then this sine theta will be b, not in this case not a mod, b vector dot n vector divided by mod of b vector mod of n vector. Just like the same as I told you that n vector is the representation of a plane. N vector is the plane which n vector is the vector which is perpendicular to the plane, and it represents the plane. So we have to calculate the theta between these and these. So that will be 90 minus theta. Hence we are calculating sine theta. So that will be this. Okay. Now condition for perpendicularity in this case will be L by A is equals to M by B is equals to N by C. You can see that they have interchanged because this angle is different. Sine theta, it is sine theta here. So in the Cartesian case, it is L by A is equals to M by B is equals to N by C will be the condition for perpendicularity. In the vector form, it will be B vector cross N vector is 0. because sine theta, we are dealing with sine theta here, so b vector cross n vector will be 0. But for parallel, this is for perpendicular. Okay, for condition for parallelity is AL plus BM plus CN is 0, just like we had in perpendicularity. In case of two vectors, this is interchanged with parallel. Okay, here now b vector dot n vector will be 0. Okay, so we have conditions interchanged, and these are the conditions for parallelity and perpendicularity of a line and plane. Now, condition for a line to lie in a plane. Condition for a line to lie in a plane. That will be, first of all, let's say Cartesian form of a line is x minus x1 by L is equals to y minus y1 by m is equals to z minus z1 by n. This would lie in the plane which is given as ax plus by plus cz plus d is equals to 0. In this plane, if ax1 plus by1 plus cz1 plus d is equals to 0 and al plus bm plus cn is equals to 0. Because if there is a plane and there is a line on that, so that n vector will be always perpendicular to this line. Okay, so that's why you can always tell that either this line is this, then also it will be perpendicular. If this line is this, then also it will be perpendicular to this line. So that's why this condition will be there. Fine. And ax1 plus by1 plus z1 plus d will be 0. This is the condition for a line to lie in a plane. Okay, this is lie in a plane. Then we have skew lines. Concept of skew lines. This is mainly asked in JEE. It was asked when I was giving JEE. So the straight lines, this skew lines topic. Skew lines. These are lines like, if you can see this as a line going backwards in the z direction for you, and this is a line. Okay, then these two lines will be skewed. They will not intersect. They are not even, let's say this is the line. Okay, this is the line and this is the line. This is going in the northeast direction, this is going in the west direction. So they will never meet. Okay, they are in space, so you can imagine that they are not meeting and they are not even parallel. So these are called the skew lines. They are neither parallel nor perpendicular. So the straight lines which are not parallel and non-coplanar, they do not lie in a plane. The straight lines which are not coplanar and not parallel, that is non-intersecting. Okay, these are called skew lines. And if delta, which is equals to let's say alpha dash minus alpha, beta dash minus beta, gamma dash minus gamma, and L, M, N, L dash, N dash, N dash is not equals to 0, then lines are skew. These are the coefficients of line. These are the direction cosines of the lines. Okay, we have two lines, so they will be skew if this condition is followed. Then the next condition is that vector form. If you are given two lines in vector form, then these can be the equation of two lines, a2 vector plus lambda b2 vector. Fine. So to be skewed, there must be B1 cross B2 dot A2 minus A1 is not equals to 0. This condition is satisfied. If this condition is satisfied, then they are called to be skew lines. In my JEE exams, these two were given and it was asked that are they skewed or not. What is the type of these lines? Are they parallel? Are they perpendicular? Are they skew or none of the above? So in that case, you have to satisfy all the three conditions. Okay, then we have shortest distance between these two lines. And this was the extension of the question, that what is if they are skewed, then what is the shortest distance between these two lines, skewed lines. So the distance will be D is equals to A2 minus A1 cross B vector divided by mod of B vector. This is a formula I want you to remember because it was asked in my JEE exam directly and it has been asked in many exams. So it will be good for you if you remember this. Okay, so this is the formula, and this is not lambda. I have written lambda dash. It can be lambda dash, can be lambda, anything. Okay, now the last point about this chapter is about sphere. Now a sphere, general equation of sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is 0. A sphere is, many circled planes, many plane circles, is formed of many plane circles. So this is the general equation of a sphere. The center for this will be minus u minus v minus w. It's just like a circle. In that case, in circle we have x square plus y square plus 2gx plus 2fy plus c is equals to 0. In that case, minus g comma minus f is the center. In this case, we have these three constituting the center, and the radius will be root over u square plus v square plus w square minus d. There is also the extension of circle. In that case, radius is g square plus f square minus c. So in this case, this is the radius of the sphere. Here we end our 3D geometry.